Welcome back to HET STEM. Today we're going to be watching a video about Tennessine. And we only have one more element after... We only have one more element after this. It's kind of sad. The series is going to be done already. Well, let's get into the video.
Maybe a slight argument about how you pronounce the name of element 117. I would pronounce it Tennessine, like iodine and chlorine, but some people in America say chlorine and iodine. But my feeling is that everybody will say Tennessine because it sounds just like the state of Tennessee, whereas Tennessine doesn't. The reason why it was called Tennessine is because Tennessee is the home of the Oak Ridge National Laboratory, where the berkelium that was used to make the element, to synthesize it, the heavy target was made out of berkelium, and the berkelium sample was prepared in Oak Ridge. Then, as before, we accelerate a light atom, calcium-48, a very expensive isotope of calcium, into the berkelium and make element 117 Tennessine. Now, I think that the interesting things about Tennessine is to speculate about the chemistry. The first thing is that you could wonder about its color if you could get a large lump of Tennessine. If you go down group 17, fluorine is almost colorless, slightly green, and then as you go to bromine is red, iodine is a dark purple color. Nobody knows what astatine looks like, and it's possible that Tennessine might be a black gas, which would itself be really quite exciting. Now, unfortunately, the way these experiments are done...
Black gas sounds kind of scary. Imagine if it was poisonous, which I think, since it's near the end of the periodic table, it's probably radioactive. But what if there was just black gas seeping into your vents? It'd be really freaky.
Is that although you would expect Tennessine, being a halogen, to exist as two atoms, Tennessine 2 just like Cl2, you only make one atom at a time. So it's like some rare species of animal. There's just one in the zoo and you can't find a mate. So we'll never know what Tennessine 2 looks like because we can never get two atoms at the same time. I would predict that Tennessine 2 would have a very weak bond, possibly the weakest bond between two atoms of the same type that actually bond together. For example, helium doesn't bond to anything, but it would be a very, very weak bond. The other thing which is interesting is to have a flight of fancy. Imagine what some of the compounds would be like. And the one I would really like to see is francium tennesside, a bit like sodium chloride, but with francium, the element which loses an electron most easily from the alkali metals, and tennessine. And I would predict that francium tennesside would form crystals which are really quite flexible. If you take cesium iodide, higher up the periodic table, you can bend crystals of cesium iodide without breaking them. You could probably make springs out of francium tennesside, but it's so radioactive that you would be got by the radioactivity long before you made the spring.
If you made a francium tennessine spring, it would kill you before you'd be able to use it. Thank you so much for watching, and we'll see you next time. Stay smart. Bye!